Let's explore demultiplexers, also known as data distributors. A demultiplexer is a combinational circuit. It accepts a single input data line and routes it to one of several output lines. The selection of the output line depends on the selection control signals. The basic concept of a demultiplexer is to take one input and distribute it to n outputs. It takes one data input and routes it to one of many outputs based on the select lines. We can represent this with a simple diagram where the data input goes into the demultiplexer, and based on the select lines, the data is routed to one of the available outputs, such as output 0, output 1, output 2, or output 3. Let's look at a 1x2 demultiplexer. The truth table shows how the input is routed based on the select line S and the data input D. If S is 0, then the output Y0 will be equal to D, and Y1 will be 0. If S is 1, then Y0 will be 0, and Y1 will be equal to D. The Boolean expressions for this demultiplexer are as follows. Y0 is equal to D and not S, and Y1 is equal to D and S. Here is the circuit implementation of a 1x2 demultiplexer. It uses one NOT gate and two AND gates to implement the demultiplexer functionality. The data input D and the select input S are fed into the circuit. The select input S is also connected to a NOT gate. The outputs of the gates are Y0 and Y1, implementing the Boolean expressions as described in the previous slide. Now let's examine a 1x4 demultiplexer. The truth table shows the outputs Y0 through Y3 based on the select lines S1, S0, and the data input D. The Boolean expressions are as follows. Y0 is equal to D and not S1 and not S0. Y1 is equal to D and not S1 and S0. Y2 is equal to D and S1 and not S0. Y3 is equal to D and S1 and S0. Here is the circuit implementation of a 1x4 demultiplexer. It uses two NOT gates and four AND gates with two select lines, S1 and S0. The data input D and the select lines are connected to the AND gates. The select lines are also connected to NOT gates. The outputs of the AND gates are Y0, Y1, Y2, and Y3, based on the Boolean expressions as described in the previous slide. Demultiplexers have a variety of applications. They are used for data distribution, routing a single data stream to multiple destinations in computer networks and communication systems. They are also used in memory systems, enabling memory addressing and data routing in RAM and storage devices. Demultiplexers can be used for serial to parallel conversion, converting serial data into parallel format for processing in digital systems. Finally, they are used in control systems to control multiple devices from a single control signal in automation systems. Let's summarize the key concepts of demultiplexers. They are data distributors routing a single input to multiple outputs. Select lines control which output receives the data. Demultiplexers are implemented using AND gates and NOT gates. The general formula for the number of outputs, based on the number of select lines, is as follows. For n select lines, the number of outputs equals 2 to the power of n. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.